In this video, we're going to look at how to solve a system of equations using the third method, which is elimination. Elimination is just as it says. In order to solve for a variable, you eliminate the other variable first. So there's a couple steps that are going to help you guys in being able to do this. The first thing you want to do is determine which variable you would like to eliminate, either the x or the y. So to do this, you have to figure out what scalar to multiply so that your chosen variable, whether you choose x or y, has the same coefficient, which is the number in front in both equations. But one has to be positive and one has to be negative. So figure out which one you want to eliminate, multiply by a certain value. The next step, once you do that, you're going to add the two equations and you should be left with one variable, either x or y. If you eliminated the x, you should be left with the y to solve for. If you eliminated the y, you should be left with the x to solve for. So once you do that, you're going to add the equations, simplify, solve for that variable. The third step then is, once you solve for that variable, so say you chose to solve for x, you would get the value of x, but your solution to a system of equations includes the solution for x and y. So if you solved for x, you need to now take that value for x, plug it back into your equation, and solve for y. Once you get x and y, write your solution as an ordered pair. So let's do an example here. I'm actually going to do letter B and letter C with you guys. So when we're solving for elimination, we need to eliminate one of the variables. So when you're looking at this, I'm seeing 2x minus 6y equals 19, and negative 3x plus 2y equals 10. So we want to see, is it easier to try and eliminate the x's, or is it easier to try and eliminate the y's? So if you're looking at the x's, you can't really easily get from 2 to 3 or 3 to 2. But for the y's, can you get from 6 to 2 or 2 to 6 easily? Yes. If we multiply that 2y by 3, that will give us 6. And then we'll have negative 6y on the top equation and positive 6y on the bottom. So what we're going to do, we can't just multiply the 2, because we need to keep the whole equation equal. We can't just multiply the 2 by 3. We have to multiply the entire second equation by 3. So it's going to go in to every single piece of that equation, and you're going to end up with negative 9x plus 6y equals 30. So what happens then is we're essentially done with the original, and we're sort of going to cross it out, and we're going to add it to the top equation. So you just add your like terms. So 2 plus negative 9 gives us negative 7x. We're just adding the two equations. Negative 6 plus positive 6y gives us no y, 0y. That's what we want. And then 19 plus 30 gives us 49. So the last thing to do is divide both sides by negative 7, and we get x equal to negative 7. So once we have x, we need to plug in that value so we can find y. And it doesn't matter which equation you guys plug it into. You just need to plug it into one of the original ones. So I'm going to plug it into the first one. So x is negative 7. So 2 times negative 7 minus 6y equals 19. So we get negative 14 minus 6y equals 19. Add the 14, add the 14. Negative 6y equals 23, 33. And divide both sides by negative 6. So we can divide both of those top and bottom by 3. And we're going to end up with y equaling 11 halves. And it's going to be negative. So our final solution here is negative 7, negative 11 and a half. So as a decimal, that would be negative 5.5, but again, I like to work in fractions. So I'm not going to make you guys check, but again, all we would do is plug both of those values back into both of our equations and make sure that they make it true and that they do work. In example C, we've got 9x minus 5y equals negative 7, and 4y minus 6x equals 2. So again, we're trying to look at the x's and y's and see if there's an easy way to eliminate one or the other. So if you're looking at the x's, and be careful because they're actually switched. They're not lined up with each other. So if you look at your x's, we have 9 and 6. You can't really easily go back and forth between 9 and 6 or get from one to the other. And for your y's, we have 4 and 5, which you also can't really get back and forth easily to. So what's going to happen is instead of just multiplying one equation, we're actually going to have to multiply both equations. I'm going to eliminate the y's, I think. And if you think what's a common number or a common multiple that both 4 and 5 go into, it's 20. So I'm going to make the top equation 20y by multiplying the whole thing by 4. And I'm going to make the bottom equation have 20y by multiplying the whole thing by 5. So just remember when you guys do this that it goes into all three things. So what we'll end up with as our one equation will be 9 times 4, so 36x minus 20y equals negative 7 times 4, which is negative 28. And our bottom equation, 5 times 4, will be 20y, and I think I'm going to actually rewrite this underneath. So 5 times 4 is 20y, positive. 5 times negative 6x is negative 30x, and equals 2 times 5, which is 10. Add them up. Your like terms, 36 and negative 30 is 6x. No y's are left, that's what we want. Negative 28 and 10 is negative 18. Divide by 6. And we get x is equal to negative 3. So now we need to find our second variable. Again, plug it into either one of your original equations. So I'm just going to plug it into the second one. So 4y minus 6x equals 2. So 4 times y is 4y minus 6 times, we now know x to be negative 3, equals positive 2. So simplify, you'll end up with 4y plus 18, because the negative 6 times the negative times negative is positive, equals 2. Subtract 18 both sides. It's an equation. Keep them equal. 4y equals negative 18 and 2 is negative 16. Divide both sides by 4, and we get y equal to negative 4. So our solution here as an ordered pair is negative 3, negative 4. And again, I'm not going to check it. I'm not going to make you guys check it on the test. You won't have to. It's just always a good idea to check to make sure that it does make your equations true and that it is a true solution. So go ahead and try letter A on your own and see how you guys make it out. Okay, so I'm on number 6 on the back page. And it gives you 2x plus y equals 5 and negative 4x minus 2y equals 10. So I'm looking at my x's again, trying to figure out, and my y's, and trying to figure out which one do I want to eliminate. Both of them are actually fairly easy. We can eliminate the x's easily by multiplying the first equation by 2 to get a 4 in front of our x. Or we can eliminate the y's also. So let's eliminate the x. And we're going to multiply this top equation by 2. So that new equation is going to be 2 times 2x, which is 4x, 2x, or 2 times y, which is 2y, equals 2 times 5, which is 10. And then we still have that second equation, negative 4x minus 2y equals negative 10. So our steps tell us that the next thing to do is to add our equations and simplify and solve. So add your x's and add your y's, and hopefully one of them should eliminate. So 4x and negative 4x is going to give us 0. Okay, well that's alright. One of them is supposed to eliminate. But then we have 2y and negative 2y, which also gives you 0. And 10 and negative 10 gives you 0. So you end up with this equation that says 0 equals 0. Well, guys, when your solution ends up with an answer that equals itself, your solution is any real number. So there's an infinite number of solutions for this equation. So, for this particular problem, there is an infinite number of solutions. Whoops. Alright, so you guys try 1 through 5 on this page, and then try numbers 1 through 4 on page 11. If you guys need to do it on a separate sheet of paper, if there's not enough room, that's fine. You guys are just skipping number 5 and 6 on page 11.